Hello everyone, Assalamu alaikum. Today we will see lecture number 8 from the subject numerical methods, and today's topic is this is the last topic in order to find the solutions of the non-linear and nonlinear equations. And today's topic is about the Newton-Raphson method, and Newton-Raphson method is also called as the open-end method. Open-end method or extrapolation method. Okay. So this is a brief introduction about the Newton-Raphson method. It's also known as Newton's method of tangents. This is considered one of the fastest iterative methods. It begins with one initial approximation. One has to take care while selecting the initial approximation. It's very important. And why? Because it's very sensitive to the initial approximations. Newton-Raphson method is considered the best method amongst the bisection, false position, secant method. So why? Because it converges faster than the false position method as well as the secant method. So let us understand this first graphically. As I told you कि हमारे पास जो है सिर्फ एक ही initial approximation होगा. For example, मेरा जो initial approximation है that is x1. Okay, what we do is we will find the function value of this f of x of 1. That means the coordinate value will be over here. How we will find the next value then? What we do is we draw a tangent from this point. हम एक slope को draw करेंगे इस point से जहाँ पे भी x axis पे ये fall करेगा. Say for example यहाँ पे इसने x axis को cut किया. This will become our next initial approximation, that is x2. फिर से we will calculate the value of f of x2. We will draw a slope from this point to this point. Say this is x3. Then again we will find the f of x3 and x3 का value. Okay. So this is the way we take the one initial approximation or single initial approximation. We calculate the value of the function जो भी हमारे पास f of x देके होगा. We draw slopes, we draw tangents. जहाँ पे भी वो x axis को कट करेगा that will become our next initial approximation. यही प्रोसीजर हम फॉलो करते 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 जाएंगे तब तक जब तक कि या तो हमें बराबर रूट ना मिले or we can get the approximated value of the root. This is how it converges the root. So अगर इसकी derivation हम देखें, so what we do is the slope of the curve at point x1 f of x1 is given by, right? We know that slopes are basically nothing, they are tangents, so equal to what we do was f of x of 1 divided by x1. जब हमने स्लोप ड्रॉ किया इट वॉज अप टू दी x1 माइनस x of 2. यहाँ पे माइनस f of x2 है ही नहीं, सो वी कैन टेक द वैल्यू ऑफ x0. वाई वी टुक दिस वैल्यू एज x0? क्योंकि जब हम स्लोप ड्रॉ करते हैं ये x एक्सिस को कट करता है. एट दिस पॉइंट वी हैव नॉट कैलकुलेटेड एनी अदर वैल्यू, सो वी टुक इट एज 0. ओके, so we can write this as f of x of 1 divided by x1 minus x of 2. You know that slopes, ये जो हमारा slope हमने calculate किया, slopes are nothing but they are always equal to the first order derivatives, है ना. So this is slope जो होता है वो हमेशा किसके बराबर होता है, is always equal to its first derivatives. So we can make this equal to, like, let this be equal to its derivative, right? हम ये लिख सकते हैं, या अगर ऐसे नहीं तो आप इसको यहाँ पे लिख सकते हैं and tan of theta is also equal to its derivative. Okay, so equating both of them what we will get is f dash of x1 is equal to, चलो ओके, इधर दिस वे और दिस वे, डोंट गेट कंफ्यूज्ड, आपकी मर्जी, आप उस तरीके से लिखेंगे या इस तरीके से लिखेंगे। किसके बराबर है ये, x1 minus x2, because slope is always equal to its derivative. What we have to find, we have to find this x2, right? So क्रॉस मल्टीपल अगर हम इसको करेंगे या शिफ्टिंग करेंगे, सिंप्लीफाई करेंगे इसको, so x1 minus x2 will be equal to f of x1 divided by f dash of x1, right? So x2 हमें निकालना है, will be equal to x1 माइनस, ये यहाँ लाएंगे तो साइंस को चेंज करेंगे, x1 माइनस f dash of x1 divided by f dash of x of 1. So this is the formula in order to find the next approximation values. अगर मैं इसको generalize करूँ, say for example the next approximation after x2 would be, say x3 will be equal to x2 minus f of x2 divided by f dash of x of 2. Okay, so अगर हम इसको जनरलाइज करेंगे, इन जनरल the I plus 1, that means the next approximation is obtained from the ith approximation as, कैसे, x of I plus 1 will be equal to x of I minus f of x of I, f dash of x of I. Okay, so this is the generalized formula for Newton-Raphson method. Let us take an example and see how Newton-Raphson method converges faster than the false position method as well as from the secant method. Okay, example. Say find the root of the equation x cube minus 4x minus 9 lies between 2.625 and 3.0. Find the root correct to 4 significant digits. Okay, so let us solve this solution. So our f of x is given, that is x cube minus 4x minus 9. Okay, so say हमारी फॉर्मूला के हिसाब से हमारा जो f of x है वो दे के है, the first thing which we have to do is what is the derivative of this function. So आपको आता ही होगा derivatives निकालना, so मैं लिख रही हूँ generally. So this will be 3x square minus 4 will be its derivative. You know constants का derivative हमेशा 0 होता है, we don't take that. Variable is, it's basically always equal to n into जो भी पार होगा n minus 1. Like x का cube है, so 3n over here will be 3. This is x, this is 3 minus 1. So this will be 3 into x का square. Similarly over here it is 1, so it is 4 into 1 x raised power 1 minus 1. Okay, it will be 4 into anything raised power 0 is equal to 1, so 4 into 1, so 4. So that is the reason I wrote it like I write 4 over here. 9 is a constant, so you have to take that equal to 0. So this is its derivative. Okay, then what we have to do is, this is our f of x, this is our f of, now our initial approximations हमारे पास दो देखे हैं why we have given two values. It is not always necessary कि आप लोगों को एक ही वैल्यू दिया गया होगा. It means from this point to this point take any of the initial guesses. कोई भी एक सा वैल्यू उठा के इन दो पॉइंट्स के बीच में आप इनिशियल वैल्यू ले सकते हो. It is always better to take a value closer to this. So let जो हमारा इनिशियल गैस है जो हम इन दोनों के बीच में से चूज़ करेंगे विल बी इक्वल टू 2.95. कभी कभी इनिशियल गैस आपको नहीं दिया गया होगा. जब नहीं दिया गया होगा आई हैव ऑलरेडी टॉट यू द मेथड दैट इज़ हाउ टू चूज़ एन इनिशियल गैस. वो हर एक मेथड के लिए काम करता है. बाइसेक्शन के लिए भी, फॉल्स पोजीशन के लिए भी, सीकेंट के लिए भी, इवन फॉर द न्यूटन रैप्सन मेथड. और अगर कभी आपको दिया गया होगा इस तरीके का क्वेश्चन जहाँ पे आपको दो इनिशियल गैसेस दी गई होंगी, तो आप इन दो के बीच में से कोई वैल्यू ले सकते हैं ताकि आपका जो रूट है फास्टर तरीके से कन्वर्ट हो जाए. आप इन दो वैल्यूज़ में से भी कोई भी वैल्यू चूज़ कर सकते हैं. हमने जो चूज़ किया दैट इज़ लेट x1 इज इक्वल टू 2.95. सो by taking this value and substituting in both the equations, so f of x1 will be equal to 2.95 का whole cube minus 4 into 2.95 minus 9. The value will be equal to 4.8724. Then taking the same value and substituting in this 3 into 2.95 का whole square, okay, square only in this part, minus 4, the value will be equal to 22.1075. Then we have to find x2 का value as per our formula, है ना. हमारी जो डिराइवेशन है या नेक्स्ट इनिशियल अप्रॉक्सीमेशन, हम नेक्स्ट पॉइंट हम कैसे निकालते हैं, बाय यूजिंग दिस फॉर्मूला. दिस x1 माइनस f of x1 divided by f dash of x of 1. Substitute the values. So x2 will be equal to, what is x1? 2.95 minus f of x1 is this 4.8724. f dash of x1 is 22.1075. After calculating this, the value which we will get is 2.7296. Okay, this was the first iteration. Second iteration is like x1 for the next iteration, or you can take x2 and calculate x3. Okay, let x1 for the next iteration is this 2.7296. मैं रिपीट कर रही हूँ. इट इज़ नॉट नेसेसरी कि आप सेकेंड आइट्रेशन में भी, मैं हमेशा क्या करती हूँ, इट बिकम्स वेरी इजी. x1 x2 x1 x2 x1 x2 इन ईच आइट्रेशन. ओनली व्हाट यू हैव टू डू इज़, जैसे यहाँ पे x2 का वैल्यू निकला, वो नेक्स्ट आइट्रेशन के लिए इसका x1 बन जाएगा एंड नथिंग एल्स. इफ़ यू आर नॉट कंफर्टेबल विद दिस मेथड देन प्लीज़ रिप्लेस इट एज इट इज़. So calculate the value of f of x1. So its calculated value will be 0.4191. Then calculate the value of its derivative. It will be 18.3521. Then calculate x2 by substituting all the values. The result which you will get is 2.7068. Okay, in the last iteration we forgot to calculate the value of x2, but over here I am doing it. आप कर लीजिए वहाँ पे भी. जो आपको पता ही है 4 significant digits तक अगर 000 आया, we have to stop over there. So the third iteration में जो मैं x1 ले रही हूँ that will be this 2.7068. So f of x of 1 will be equal to 0.0049 obviously, क्योंकि ऑलरेडी किया है. तो इसका जो डेरिवेटिव का वैल्यू है दैट विल बी इक्वल टू 17.9803. After that we have to calculate the value of x2 by substituting x1 minus f of x1 divided by f dash of x1. इसका जो कैलकुलेटेड वैल्यू है दैट इज़ 2.7065. अगर आप देखेंगे अप टू द 4 significant digits यहाँ पे 2.706 है, यहाँ पे भी 2.706 है. लेट अस डू वन मोर आइट्रेशन सो दैट हम श्योर हो जाएं. सो calculate the value of f of x2 by yourself at this point of time, which will be basically equal to minus 0.005. So x1 will be equal to 2.7065. f of x of 1 will be equal to minus 0.005. इसका जो डेरिवेटिव का वैल्यू है that will be 17.9754. and calculate the value of x of 2, that will be x1 minus f of x of 1 divided by f dash of x of 1, that will be equal to 2.7068. So again, up to the 4 significant digits the value is same, so we can write it over here. After observing the iterations 2, 3 and 4, no change is produced. Therefore, we take the root equal to 2.706. If there will be any confusion anywhere, please let me know so that we can clear that. Thank you.